All right, so we have covered vertical translations and horizontal translations. That's shifting your graph left or right or up or down. How now we're going to look at stretches and compressions of linear functions. So part A, how does multiplying the output of a linear function by a constant k affect its graph? So we're going to look at the graph of f of x equals x plus 1 and g of x equals 4 times f of x. This is what it looks like when you multiply the output of the linear function by a constant k. So essentially, we're multiplying an entire function by some constant. If we go ahead and do that math, we can do that math off on the side. G of x is going to equal 4 times the entire f of x function, and f of x is x plus 1. So 4 times x plus 1. We can go ahead and distribute that 4x. 4 times 1 is a positive 4. So our g of x function, when we simplify it, is equal to 4x plus 4. So if we look at the graph over here, here's our f function. There's the x plus 1, y-intercept of 1, slope up 1 over 1, up 1 over 1, up 1 over 1. When we multiply that entire function by 4, what it did is it multiplied our slope of 1 times 4. So we have a slope of 4. And then our y-intercept also got multiplied by 4, and now our y-intercept is a positive 4. So here's up 4, and then a slope of, probably counting by 2s, of 4 over 1, up 4 over 1. So how does the slope of g of x compare with the slope of f of x? It was multiplied by 4. That is our constant k that we multiplied the output of a linear function by. How does the y-intercept of g of x compare to the y-intercept of f of x? And that y-intercept was also multiplied by 4. And here you can see when we did that, we multiplied 4 times our slope of 1, x, and then we multiplied 4 times our y-intercept of 1. So the y-intercept is multiplied by 4. So here is just a summary of that in bold. Let's go ahead and put little stars by this. When you multiply the output of a linear function, it will scale the slope and the y-intercept by a factor of k. So when we say scales the slope, it's going to multiply the slope and the y-intercept by whatever that constant was that we multiplied the output of your function by. So in this case, we had a 4 right here. If you are multiplying the output of your function by a constant k, let's just make a note that that is what we call a vertical stretch or compression. We'll talk about the difference between those two vocab words in class, but if you are multiplying the output, the entire function gets multiplied by a constant, that's a vertical stretch or compression. So let's just look at an example. We have f of x equals negative 8x plus 6. What is the equation of g of x if g of x equals 1/2 times the function f of x? So here we are multiplying the output, f of x is the output of the linear function, by a 1/2. So I already know it's going to multiply the slope and the y-intercept by a 1/2, but we can go ahead and do that math. Let's see, g of x equals 1/2 times the entire f of x function, which is this negative 8x plus 6. We can go ahead and distribute that 1/2. 1/2 times negative 8 is a negative 4x. 1/2 times a positive 6 is a positive 3. So there's our g of x function. How does the graph of g of x compare to the graph of f of x? The slope and the y-intercept were multiplied or scaled by that 1/2. All right, so that is multiplying the output of a linear function by a constant. What if we multiply the input of a linear function by a constant k? So here's what that's going to look like. Consider the graphs. We have f of x equals x plus 1, and then g of x equals f of, see how here's our input x, we're multiplying the input by a 3. So to find our g of x function, what that's going to look like, g of x equals, it's our f function, but we're going to multiply 3 times any x's in that function, which happens to be just right there. So instead of an x, we're going to have a 3x, and then we have our plus 1. So if we compare these graphs, if we look at our f of x function is x plus 1, so y-intercept of 1, slope up 1 over 1, up 1 over 1, up 1 over 1. Our g function has the same y-intercept, we're at 1, but our slope is 3x. So up 3 over 1, up 3 over 1, up 3 over 1. So how does the slope and the y-intercept of g of x compare to the slope and the y-intercept of f of x? So the slope is multiplied by 3, but the y-intercept did not change. So here is our summary of that. Multiplying the input is multiplying just the x, not the entire function, of a linear function scales only the slope by a factor of k. The y-intercept will not change. So let's just look at one more quick example so we can kind of get the hang of what we're seeing here. Let f of x equal a negative x minus 7. What is the equation of g of x if g of x equals f of 3/4 times x? So here we are multiplying the input by a 3/4. So we are going to g of x equals our f function. So we're going to take this f function and we're just going to replace the x with a 3/4 x. So we have that negative right there in our function. Then I'm going to do a parenthesis because that's where our x is, and I'm going to plug in a 3/4 x and then minus 7. So that negative 3/4 x just makes that a negative 3/4 x and then minus 7. So there's our new function. How does the graph of g of x compare to the graph of f of x? Well, we can see that our slope of negative 1 got multiplied by our constant 3/4. So the slope is multiplied by 3/4. But if we notice, the y-intercept was negative 7, and our y-intercept is still a y-intercept of negative 7. So the y-intercept did not change. And then let's just make a note, and we'll talk about this in class. When you're multiplying the input of a linear function by a factor of k, that is a horizontal, can you even read that? That's a horizontal stretch or compression.